So in the first video, we saw what a confidence interval was. It's an interval estimate for a parameter now, no longer just a single value. And we talked about why it was important, because the estimator's value alone doesn't tell us how precise or how good that estimate is. And in the second video, we started to get a feel for how we constructed a confidence interval. And in this video, we want to talk about how we actually compute confidence intervals. So I want to start off with kind of the basic equation for the confidence interval. Confidence interval is equal to our estimator plus or minus the margin of error. And the big problem really is computing the margin of error. Okay, so for example, the estimator we get from the sample, so there's really not a lot to do there, right? So the margin of error is kind of where all the real work is involved. And the thing to remember about the margin of error is it's really a product of two things. It's a product of a z-score, and we saw in the last video how we get the z-score from the confidence level. So the confidence comes in via the z-score, and we have to multiply it by the estimated standard deviation of the estimator. So if you go back and you think about way back in chapter 3, right, we talked about the spread of the estimators. This is an estimate of the spread of the estimators around the parameter value. And we know how to get those. The central limit theorem tells us what they are exactly. So notice the word estimated here. So the central limit theorem tells us what they are exactly. The problem is that we have to know a lot of information about the population parameter to get the exact standard deviation. So instead we get the estimated. And so if we go back and we're doing a confidence interval for pi, this is our estimated standard deviation of the estimator. Notice it looks like the quantity we used to work with when we were doing the hypothesis test. The only difference now is we have sample percentages rather than population percentage, because we don't know the population percentage. And that in fact is the entire point of the confidence interval. So we have to kind of fudge a little bit and use the sample percentage since we don't know the population percentage. If we're looking at the population mean, here we use the sample standard deviation rather than the population standard deviation. That's why we have sigma hat. The hat's indicating that it comes from a sample. Okay, now it's important to understand that how the confidence level and how the sample size come into the margin of error, what they do with it. So notice here what's happening as the sample size increases, right? As the sample size increases, the standard deviation of the estimators go down. And we've known this since chapter 3. Way back in chapter 3, we made this observation that as the sample size gets larger, the spread of those estimators has to decrease. And so as the spread of the estimators decreases, the standard deviation gets smaller and the margin of error decreases also. So as n increases, the spread of the estimators decreases and the margin of error decreases. Conversely, as the sample size decreases, the margin of error increases. Exactly that same sort of reasoning. How does the confidence level come into play? Well, the confidence level is those numbers that we give when we're talking about the confidence, the 95, the 99, the 90, okay? And as the confidence level increases, the margin of error, our error bar, also has to increase. And so one way that people generally think about this is we say something along the lines that if we want to be more confident that our confidence interval contains the true parameter value, what should we do to the confidence interval? Well, we should make it wider, right? If we had a wider confidence interval, we'd be more confident that it contained the parameter value. And that's one way of kind of rationalizing this, okay? So our error bar around our sample estimator should get wider, okay? If you want to think about it in terms of the last video, you could realize that the confidence level came into play when we were looking at the distribution of estimators. So when we constructed, for example, a 95% confidence interval, we made this with our margin of error, and it contained 95% of the sample estimates. And so as this confidence level increases, our margin of error gets pushed out. It has to become wider. So there's a lot of different ways of kind of rationalizing this and looking at this, okay? What I want to do now is I want to actually look at how we do this calculation in Excel. So what I'm going to do is I'm going to pull up a template, and I'm going to look at how we compute the confidence interval for the sample proportion. Okay. And I'm going to go ahead, I'm going to erase all this because we don't need this. And we're going to see how to put this together. And what I want to do is I want to start thinking about, okay, what do we need for our input? And if you want to, you can stop the video right now, and you can go ahead and copy all this down, okay? And let's think about the input for a second. So I want to look at the formula for the confidence interval. I'm going to go ahead and I'm going to write it out here. So our formula for our confidence interval looks like this. Our estimator, of course, we get from our sample. So we can compute this from our sample. A lot of times we'll be given the estimator, right? But if, for example, if I give you a data set, you can compute the sample mean from the data set, right? You can compute the sample percentage. So we're either going to compute mu hat or pi hat. Our margin of error, well, our margin of error is going to be our z-score, which is going to be the z-score for the 1 plus confidence level divided by 2 percentile times, and now we're going to use whatever the estimated standard deviation is for our estimator. So if we're looking at pi, this is going to be pi hat times 1 minus pi hat divided by n square root. Or if we're looking for the population mean confidence interval, this will be sigma hat divided by the square root of n. So we see what we need for our input. Our input, and I'm going to do these for pi hat, for pi and mu separately, okay? So our input that we need for pi is we're going to need pi hat, we're going to need n, because this is coming into our estimated standard deviation for pi hat here, and we're going to need the confidence level. Okay, so notice that when I did this template, this is what I had. The sample size, the confidence level, and sometimes you might be given the raw data. So here you're going to have to compute the number of successes, right? And then our sample percentage. So let's go ahead and do this for a particular data set. What I'm going to do is I'm going to use the data set for the error barometer here. Let's see, which data set did I use? 2012 or 2016? I used 2016. So let me go ahead and do that. So this is the barometer data. And this is a fascinating data set. This is, although it's not a formal census, this is a data set that a number of large universities collect. It's quite comprehensive. And I'm going to go back and look at some of the questions that they ask. And this is only a very small snippet. So one of the questions they ask is, do you think that people can criticize the government without fear? This is question 217. Yes, no, I don't know, decline to answer. So let's go ahead and pick a country. I'm going to pick, let's look at all the countries that are available to us here. So we have Algeria, and it's a huge data set. Okay. Oh, maybe I cut them all out and I only kept Algeria. No, I didn't. Hold on. Yeah, there's all of them. This was a second sheet where I kind of pared it down, right? So we have Algeria, we have Egypt, Jordan, Lebanon, Morocco, Palestine, Tunisia, and that's it. And let's go ahead and pick Tunisia. Tunisia and Egypt are very interesting because that's where the Arab Spring started. So what I'm going to do is I'm just going to find all the data values for Tunisia. I'm going to copy and paste it. I'll, I'll create a little sheet here called Tunisia. Okay. And I'll go back to here and I'll just find all the data values for Tunisia. And what this will show you is this will show you how to construct a confidence interval from raw data, which is actually harder than if you have the summary statistics, right? So here's all the data for Tunisia. We'll click here and copy all this. I won't cut it because I might want to come back and use information about another variable from Tunisia. And there we are. I'm going to go ahead and copy this, and I'm going to paste it here. And what happened? Let me open up a new sheet because I don't know why that shouldn't be showing that. There we are. And that was the very first question. Let's go back and kind of look at all the questions here. This was the very first question, so it should be, if I did this correctly, it was question 217, which is column D. And let me just check and make sure that's exactly what we're looking at. Question 217. And so I want to create a confidence interval. What I want to do here for question 217 is I want to create a 90% confidence interval for pi, where pi is equal to the percentage of people in Tunisia who feel they can criticize the government without fear. Okay? So I'm going to go back to this data set and I'm just going to cut out everything except the values in column D. In fact, I don't even need the country names or anything. All I need is just the raw data here. So we'll just take all this out, delete, and delete. And all I need is this data. So now I'm going to have to count, right? I'm going to have to count the number of people that said yes, the number of people said no, and of course the total. And so if I do this, I'm going to have to use COUNTIF, right? So I'm going to say COUNTIF all the people in the data set. And it's been a little while since we've done this command, right? So remember, we'll put a comma and then we put a double quotation mark, equal yes, end of double quotes. And I need an equal sign, not a plus there. Okay. And I should sort also. So let me do this. We should always sort and look at the data, okay? Because there's going to be some people that that are don't know, and we don't want those, right? So what I'm going to do is I'm going to go back and resort from Z to A. Okay. So there's 957 that said yes, and I'm going to take out the ones that say don't know. I can't do anything with them really. So I'm going to kind of ignore them. And we're going to see when we look at the data set, they're actually a very small percentage of the data set. So if we look at this, we don't have that many values. So we could lose those, and it wouldn't affect our data set tremendously. And now I'm going to count the number of no's. So all I'm going to do is I'm just going to copy and paste this and change the yes to a no. And of course the total I'm going to check, right? Should be this plus this. And this of course is my sample size, right? And I'm going to check. Notice that I'm starting at row 1, so I should have data in 1,169 rows. And I'm just going to skip down there and make sure that's true, and it is. My last data value is on row 1,169, so I done good. Okay, so now I'm going to go back and use this data. So I had 957 successes. When we say success in statistics, we don't necessarily mean it was a good thing. We just mean that we found what we were looking for. And what were we looking for? The people who said yes. Okay. So now I'm going to compute my sample percentage, right? So this will be equal to the number of successes, the number of people who said yes, divided by my sample size. And that's the sample percentage, right? And my confidence level, I said, was 0.9. Okay, so that's all of the input for this data set. Okay. Now I'm going to have to compute this z-score. So now I'm ready to start to put together the margin of error calculations. So first I'm going to compute the z-score. And I'll show you the easy way to compute the z-score. So what I'm going to do is I'm going to do norm.s.inv. And the reason why I'm going to choose S is S stands for the standard normal. This calculation is easy. Notice it's not asking me for the mean and the standard deviation like the usual norm.inv does. Why? Because for the standard normal, by default, we know the mean and the standard deviation. The mean is 0, the standard deviation is 1, so there's no need to compute it. Now the probability is a little tricky though. I want to show you this. So I'm going to start to put a parenthesis there, and I'm going to say 1 plus my confidence level, and then I'm going to close the parenthesis and divide it by 2. So notice that I'm dividing the entire quantity 1 plus the confidence level divided by 2. And the reason why I do that is this gives me the confidence level for the upper end, which that percentile, the value for that percentile is going to be positive. You could do confidence level 1 minus confidence level divided by 2, but you're going to find that you're going to get a negative value. So that's my z-score. Now I want the estimated standard deviation of pi hat. So I'm going to say square root, and then I'm going to say pi hat times the quantity 1 minus pi hat divided by the sample size, and I'm going to take the square root of that whole thing. And it's good that you're working along because you can check and see if you're entering it correctly. So if you didn't get that value, you might want to go back and look and see why. Here, I'm going to do this really quick. So there's the value that you should have gotten, and there's the command that you should have used. And if you're getting an error, ask yourself, do you have this command entered in exactly the same way? And what really screws people up is they don't have that 1 minus pi hat, the cell wherever pi hat is, that whole thing contained in parentheses. So you want to be careful about that. Okay, now we're ready to compute the margin of error. Real easy. Z-score times the estimated standard deviation of our estimator. So this times this. Okay. And now we're ready to do the calculation, because what is our confidence interval? Well, our confidence interval is just the sample percentage minus the margin of error plus the sample percentage plus the margin of error. So I'm gonna click on wherever pi hat is. In this case, it's here. And I'm going to subtract the margin of error, which is here. And I'm going to multiply it by 100% because usually when we're computing the confidence interval, we like to think in terms of percentages. So let me kind of gussy that up a little bit. There we go. Very interesting, quite high, right? And all I have to do is copy and paste and change this to a plus. So this says that my 90% confidence interval for the percentage of people in Tunisia who think they can criticize the government without fear is between 80% and 83.7%. We think the true value, pi, lies in this interval right here. And that's how we do a calculation for the confidence interval using that's how we do a confidence interval calculation for a population proportion. There we go. Okay. Now let's look at how we do that same sort of calculation if we had a confidence interval for a population mean. So what would we have to enter as input? Well, we're going to again need sigma. We're going to need mu hat. That's going to be our estimator, which is going to be the center. We need sigma hat, the sample standard deviation. We need n, and we need the confidence level. Okay? And so let me just make up an example. Let's just say that Bardo, remember he's our beloved baker, he wants to compute a 99% confidence interval for a population mean, where mu, as you might guess from our previous examples, is the average weight of his loaves of bread. Okay? And let's suppose Bardo goes out and he takes a sample of, say, 20 loaves, and he finds that the sample mean from those 20 loaves is 16.2 ounces. And he finds that the sample standard deviation of the weight from those 20 loaves is equal to, let me think about this for a second. We'll say 0.5 ounces. And now we want to go ahead and we want to compute a confidence interval from this data. Let's see how we would actually go about doing that. Well, let's just enter all of this information, right? So now you could make a second sheet for confidence interval calculations. And if you want to, you could pause this video, right? The input you're going to need is a sample size, the sample standard deviation, the sample mean, and the confidence level. And so if you want to pause the video and copy this down, type this into a blank Excel sheet, that would probably be a good idea. So I'm going to assume that you're ready now, and I'm going to enter these values from our problem here. Okay, so I'm going to take out all this. So our sample size here was 20, and the standard deviation of those weights of loaves was 0.5, right? That's the standard deviation, sample standard deviation of our variable, and the sample mean of our variable was 16.02 ounces. And Bardo wanted a 99% confidence level, and we always enter the confidence level as a decimal. Now the cool thing is that the z-score is computed exactly the same way. Okay, so again, I'm going to use norm.sinv because that's the easy way of doing this, right? And I'm going to use exactly the same command I did for the population proportion confidence interval. 1 plus the confidence level, the entire quantity. So notice I have that 1 plus the confidence level enclosed in parentheses, right? Divided by 2. And then we find out that that z-score is 2.576. Now, if we want the estimated standard deviation of the sample mean, I'm going to take the standard deviation of the variable and divide it by the square root of my sample size. And again, if you're getting the wrong value, pause this video. Go back and look and see what I did and then look at what you did. You can kind of pause the video. Make sure that you're entering it the same way. And you should get 0.112. And now the z-score is computed always the same way, right? It's whatever our z-score is times the estimated standard deviation of our estimators. That's the estimated spread of the estimators, the sample estimators, right? And we get 0.288. And now again, the confidence interval is computed exactly the same way as for the confidence interval for the population mean. I'm going to take whatever my estimator is, here it's my sample mean, and to get the lower endpoint of the confidence interval, I'm going to subtract the margin of error from it. Whoops. Didn't want to do that. And my margin of error is there, and there we go. And now I'm going to go ahead and I'm just going to copy and paste that below and change the minus to a plus sign. And this gives me the upper limit, or the upper end point of the confidence interval. And I definitely did something wrong there. So let me just enter it by hand, okay? So let's think about the interpretation. So what this interpretation is we're saying that Bardo believes that the true value for the average weight of all of his loaves, based on his sample, is roughly 15.9 ounces to 16.5 ounces. So this is the estimate for the range of values that he thinks the true value of mu can lie in. Okay. We're going to talk more about the interpretation of the confidence interval in the next video. And the thing that I want to super impress upon you is that Bardo is not saying that he thinks there's a 99% chance the value is in here. Okay. He's just simply giving an estimate for the range of values. And we all know that estimates can be wrong. But we can't put a probability once we've computed the confidence interval. We're going to talk more about that in the next video.